Hi, this is Professor Elliott, and today we're going to take a brief look at the window comparator. The window comparator is a commonly used circuit in industry, basically to provide an output when the inputs are, between or above or below certain preset thresholds. So in the circuit number 1, our first circuit, we can see that we have 2 op amps. Okay, so our input is being provided by basically the variable resistor R3, and notice how that input voltage is fed to both of the comparators. We have 2 outputs, LED1, LED2, and in this case EI, the input voltage, is less than LTP, called the lower trigger point or the lower threshold. So in this situation, we have the input EI is between the lower trigger point and the upper trigger point. And in this case, the output of both comparators is high. So that means both LED1 and LED2 are turned off. They're reverse biased. Okay. Now we have EI is increasing now. So EI is now just equal to or just slightly exceeds the upper trigger point. Notice how LED2 is turned on. That's because the output of comparator U1 is low, or basically at ground, and the output of the other comparator is high. For circuit number 2, just a little bit different arrangement. Notice how the LEDs, they're turned around the other way. So in this case, turn the LEDs on, we need the comparator output to be high, where in the other circuit they needed to be low. Same idea, just slightly different arrangement. Okay, so here's how we do the calculations for the LTP and UTP. It's just basic voltage divider. So in this circuit, the lower trigger point is equal to 1.36, and the upper trigger point, UTP, is equal to 4.69. And the input voltage is set by the variable potentiometer, which in the real life would come from a pressure transducer or some sort of sensor which provides a variable voltage output. So in the first case, the input voltage is set to Vin, and in this case Vin is greater than or equal to the upper trigger point, which is our 4.69. Therefore LED1 is turned on, so the output of U1 is at plus Vsat, and U2 is at minus Vsat, so therefore LED1 is on and LED2 is off. Now we have the input voltage is now equal to 4.5 volts, which is between the LTP and UTP thresholds. Therefore, both LED1 and LED2 are turned off because the outputs of U1 and U2 are both at minus Vsat. Okay, and this arrangement, the input voltage is down to 0.75. You can see just by adjusting the potentiometer R7 is how we're simulating our variable input voltage. So in this case, the input voltage is less than or equal to the lower trigger point. Therefore, LED2 is turned on and LED1 is off. U1 is at minus Vsat and U1 is at plus Vsat. Okay, for our final circuit, circuit number 3. Okay, so I've added some logic gate circuitry at the output, and added a third LED, so that LED3 will be on when the input is between the lower and upper trigger points. So I just provide just a little bit more control for us. Okay, so once again, calculating the LTP and UTP, it's just simple voltage divider. So we have 0.833 and 2.94 volts respectively. And this time we're running everything off 5 volts, so it's LS-TTL compatible. So our input voltage is 2 volts. The input voltage is between LTP and UTP. Therefore, the logic gate circuitry then ensures that LED3 is turned on, and the upper trigger point and lower trigger point, LEDs 1 and 2 respectively, are of course both turned off at this point. So in this case, our input voltage Vin is equal to 3.2 volts. So Vn is equal to or greater than the upper trigger point. Therefore, LED 1 is on, and of course LED 2 and LED 3 are both switched off. Notice for this circuit that the output of the comparator, when it's in a positive VSAT, then the LED will be on. So it's just a little different arrangement than the last circuit. So in our final slide, our input voltage is equal to 0.5 volts. So Vn is equal to or lower or less than the lower trigger point. Therefore, LED 2 will be on, and LED 1 and LED 3 will both be turned off. So that's pretty much about it. I know we went through this fairly quickly, so I'm going to ask that you spend some time, print out the slides, review this presentation, and make sure you spend the time to understand how this works. Everything is there on the slides for you, because you're going to be building circuits like this in the lab. See ya.